We will now determine the exact value of modulus of w as well as the argument of w. So first, I'm going to use this equation and simplify w so that I get in terms of a plus bi, so that we can find the modulus as well as the argument. So let me take this equation. We have w over z equals 2 plus 2i. So let me multiply both sides by z. So I get w equal to z times of 2 plus 2i. We are given the value of z, which is again a constant, which is once again another complex number. So we can replace this complex number here. That is z equals 1 plus 3i. So therefore this becomes w equals 1 plus 3i times of 2 plus 2i. So basically we have to FOIL this out. Let's do that. So I'm going to multiply the last two terms, that is 1 times of 2 is 2, and then 1 times of 2i is 2i, then 3i times of 2 is 6i, and finally we have the last outer terms, that is 3i times of 2i is 6i square. We know the value of I squared equals negative 1. So I can replace this as I squared is negative 1. So therefore this becomes negative 6. Now let's combine the real part. The real part is 2 and negative 6. So 2 minus 6 is negative 4. So we will have negative 4. And the imaginary part is 2i and 6i. So we can add these two. We get 8i. So now this w is in a plus bi form, where a is negative 4 and b is 8. We can determine its modulus. The modulus formula for a complex number a plus bi is a squared plus b squared. So we will replace this formula. So therefore we write the modulus as modulus of w equals a is negative 4. So this becomes negative 4 quantity square plus b is 8. So this becomes a quantity 8 quantity square. So this gives negative 4 square is 16 and 8 square is 64. So therefore this is equivalent to 64 plus 16 is 80. In fact, we can simplify this. 80 can be written as 16 times of 5. So therefore root 80 will become uh, square root of 16 times of 5, and this equals square root of 16 times of square root of 5. We know the square root of 16 is 4. So finally, this is simplified to 4 root 5. So therefore, the modulus or the exact value of the modulus of w is 4 root 5. So let's now find the argument of w. So for this, we have to use the reference angle formula. So first we'll find the reference angle formula using this. That is theta reference equals tan inverse of p over a. And here both b and a are positive. That is, we ignore the sign of the b and a. So therefore, the reference angle equals tan inverse of b is 8 and a is 4. We ignore the negative of a. So therefore, this is basically equivalent to tan inverse of 8 by 4 is 2. So this is the reference angle. We now plot this complex number negative 4 plus 8i in the complex plane, and then determine which quadrant the reference angle or the exact angle lies in. So this is negative 4 is to the left of y. So let's say this is negative 4, and 8i is 8 units above the x-axis. So let's say this is 8. So this is the point negative 4 comma 8 in complex plane. That is, if you consider this as real axis and considering this as imaginary axis. So this is our angle. So basically we have to determine this angle, knowing that we have the reference angle is tan inverse of 2. Since this point lies in quadrant 2, In quadrant 2, we say the exact angle equal to, let's say the exact angle. So this equals 180 degrees minus of reference angle, theta reference. So therefore this becomes the exact angle of, you can write down this as exact angle of the complex number W. This equals 180 minus of theta references, that is reference angle is tan inverse of 2. So this is the exact value of the argument of W.